So BIP2 format data is up till 2021. So the version right now I am using is 3.7. We have simulated for this time period many times, and this is compatible with this kind of this version 3.7. As I have faced problems with recent data with old version of model, so I am going with the 2010 data version only. So from here I can select months, I can select hour data or the whole month data or whole year data. Different options are here. The direct download option is not so direct download option comes like this, but it will be hard to download each of these file like this. So we download a script, that is CSH download script, and run it to download all the files at a time. So to download using that script, we have to give this command. This is the command line, the first line of this attached photo, that is CSH download underscore ds. This is the command actually. CSH is the type of the script language, and after giving this command, this portion, that password, here you have to type your login password of the site. Then the download will and then the data will get downloaded in the directory where you have kept this script. So any doubt over this downloading process? In the earlier class, we have already downloaded data, so I'm not downloading it now. I will show you the data location which I have downloaded. This data was downloaded 2010 January month data for 1 day only. 6 hourly gap is there. So 00 start from 00, 6, 12, 18, and day 2. Day 2 fast hour. So this is the downloaded data, and this is time varying data, and these are global data sets. Like this content data of the complete globe. This is not domain based data. Means from here there is no option to select a domain. So we have downloaded a global data set. And this nameless control file is okay with the dates, is okay with the number of grid points, is okay with the domain position, and is okay with the type of map projection. So we will start our simulation on this. On the first, we run GeoGrid. It will extract data from the geostatic database. After complete extraction of data, the successful extraction of data, a successful comment comes out. So we are sure that the data is successfully extracted. Now we go to ungrave process. Ungrave is extracting data from the time varying data. So here, some steps are very important. We have to give this command. Link the variable table. Variable table contains the variable which we gonna extract from the time varying data. So we are linking that variable table. So here the variable table is located at folder ungreep, variable tables, and exact table is vtable.jfs. I will show you vtable. There is the table. See here are the variables already mentioned: temperature, wind, component UV, and other variables. There are many tables are present here. We are selecting this table only, vtable.jfs. You can select different table as per your research work. Now we have to give the data location, the data location of the time varying data. Time varying data is present here. These are the commands. Okay. Now we have to run the uncrypt process. It successfully extracted time varying data by using the variable table as linked. Now the final step of this WPS. So it is also successfully complete. So now we will check the data which we just generated now. Like checking will be done to see that our domain size is okay and the data has the variables we required for the CTM model or not. These two data was generated after running this command under /matrix.exe. This is a tool, panoply tool, which we use to we visualize and extract data from netcdf files. So here the meteorological file got generated for this domain. Here as you see here. So let me So this is a domain of meteorology data extraction, which will finally go ahead with WRF with this domain only, and means for the final simulation. So any doubt till now? So still up till this part we have completed running medread and obtaining the metem files. Now we'll go to WRF for finally simulating and building the boundary conditions, initial conditions. This metem files was created using WPS. At last we got these metem files, and now we have to link these metem files to WRF to get the initial conditions and boundary conditions, and then finally simulate. This is the this WRF has many folders, so you have to keep this folder name in mind, that MDL folder, test MDL. In MDL folder, you can file README file, README, this one readme.namelist. Here you can get the details about different namelist option, like what they actually means. So every controller given here, so you can refer here if you are not understanding any one parameter from the namelist control file. So we will just modify some basic namelist. This one is the main control file of this simulation. This is the file. So here at first number of run hours modify 0. So right now we are trying to run, we will run the simulation using the domain which we chosen as an example. So as per that time period, I am modifying this English control file. Start month, start date, start hour. There are various controls. We will get to know this. Time step is one of the important parameter here. As per this notification, after 10 minutes, this link will expire on Zoom. Then I will open the same link again. Then you can join. So here where maximum domain is 1 means nesting option is available here. So in nesting option more than one domain is required, but here no nesting option is used, so we are using only one domain. Here the option is 1. Now we have to modify this part. We have chosen 50 by 50, 50, 50, 50 by 50. Let it be what it is, dx dy. It is resolution. There are many options. There are physics options, dynamic options. But right now I have modified only the main options for our domain, the number of grid points and the resolution and the time period. Again, going back to the terminal. So here you can see the folder location. Show you. Using this command, I have linked the metem files here where the final simulation will run. You will not get this thing. These are actually all commands. So at first you will have difficulties on understanding this command. These are actually folder directories. So double dot slash means a directory back. So you will know time you will get to know this command. Now let's check if the files have been linked properly or not. Yes, it's linked. You can see I have listed. This ls means list file with name metem star. You have listed the file. Two files are present here, linked file. So their color are different here. Now I want to run. We have to run this first step of WRF, that is real exe, to build initial boundary conditions, initial and boundary condition. This is initial condition file and this is boundary condition file. So it crashed. It crashed at a point. It's saying that dx dy should be as per their formulation, and the metem file info. The dxdm dy will be 117.7480. So we have to modify the name list file according to this number. So I have given here 10,000, 11,117.7480. The same comes up here. So, save. We successfully prepared initial conditions and boundary conditions. So let me list those files. These two files has been prepared right now only. So the dates also. 12th November right now. These two files have been prepared. This contains the boundary conditions. This contains the initial condition. Now we are ready to run our final simulation on WRF that will generate give us the meteorological data which we have to provide to CMAR for further simulation. The last command is .wrf.exe, runs the model simulation and gives us this output. We will run this command. The simulation has been started. So you can follow this time 0306, like 3-minute gap. 3-minute gap as the time step here it is 180 seconds. This is in second, in terms of second. It already reached 11th hour and finally it's completed the simulation. As we have chosen a smaller time period, so it took very small time to simulate, and the domain size was also very small. So if you are practicing in your system, there will be no problem in running smaller domain dimension. You can run in your system, but for WRF and WPS, you need Linux like Ubuntu or CentOS operating system to install it. So we have prepared. We have completed a simulation. See, this file has been generated right now only. This is our final file. So again, we will open this file using Panoply 2. Pressure. This is the pressure variable P. These are the vertical heights, vertical levels. So in the nameless control file, you can see we have chosen 30 number of vertical levels. 30 number, including 0. So any doubt on this? We can end our class here. We have prepared the class. Any doubt?